Hello, this video is for IXL Activity A1.L.1. It is titled Solve Absolute Value Equations. The 3-character code for this activity is Niner Lima Foxtrot. And our first question asks, how many solutions does the equation have? We have the absolute value of 3 times f is equal to 12. Well, whenever we solve absolute value equations, there's a few steps that we have to do. First, we have to isolate the absolute value portion of the equation on one side of the equation, and then we'll have some values, some constants, over on the other side of the equation. So here we can see that the 3f, the absolute value of 3f, is already isolated by itself on one side of the equation, and then on the other side of the equation we have 12. And then the next thing that we need to do is, after isolating the absolute value portion of the equation on one side of the equation, we then have to create 2 special cases, in which we have one case where we take what's inside of the absolute value and then we set it equal to a negative version of what we see on the other side of the equation. And then the second case where we take what's inside of the absolute value expression, the 3f, and we set it equal to a positive representation of what we see on the other side. So here we have 3f equals negative 12 or 3f equals positive 12. The reason for this is, if we take the absolute value of x, we know that it equals positive x. But also, if we take the absolute value of negative x, it equals positive x as well. So you see that we have a positive version and a negative version concept here. So that's why we have to set up 2 special cases in which one of them is positive and one of them is negative. Now, from here, we would then go ahead and solve each of these little mini equations that we've created from the original equation and see what those solutions are. Well, if we do that on the first one here, divide both sides by 3, we would get negative 4. And then over here on the next one, if we divide both sides by 3, we would get positive 4. So we see that the solutions here are either negative 4 or positive 4. We could check that out if we take and substitute that in. 3 times 4, the absolute value of it, well, that would equal 12. And the absolute value of 12 indeed equals 12. Now, if I did the other way, if I took the absolute value of 3 times negative 4, and 3 times negative 4 is negative 12, but the absolute value of negative 12 is positive 12. So we can see that indeed our answer does check out. Now, one thing that you noticed about the first question here is it's not asking us for the solution. They just want to know how many solutions are there. Well, we can see that in this case there are 2 solutions. Now, from the other answers that are possible answers, no solution and 1 solution, we might reason that there is a way in which you would only have 1 solution or possibly no solution. So let's go ahead and take a look at those situations. I'm going to go ahead and erase this here. What would it look like if we had no solution, or if we had just 1 solution? Well, what if I had 3f, the absolute value of 3f equals 0? And I would try to create 2 separate equations from that. 3f equals negative 0, and 3f equals just positive 0. Is there such thing as negative 0? And even if we did this, we would end up with, well, I guess, what, a negative 0, f would equal negative 0. That just doesn't seem to make sense. So since there's no such thing as a negative 0, we end up with just 1 answer in a situation like this. So when would it be only 1 answer? If after we have isolated the, my brain just lost it, the absolute value portion of the equation on one side, and on the other side it's set equal to 0, then we know that there's just 1 solution. Now let's look at another situation and see if we can come up with when would there be no solution. Well, we have here that, let's take the absolute value of 3f again, just using that for an example. Let's set that equal to, let's say it was negative 12 instead of positive 12. Well, one thing that we know from our example over here that I wrote down over here is that the absolute value of a positive number is a positive number, and the absolute value of a negative number is a positive number. Notice that whether we have a positive or a negative in here, they both produce positive numbers. Well, in this situation that I have here, this is producing a negative number, and that's not possible because you see, absolute value is all about distance on a number line. So if we had a number line and we had a spot here and a spot here and a spot here, and this value is 0, and this is 2 or -2, and this is +2, notice that this is 2 units away from 0, and +2 is also 2 units away from 0. So absolute value is all about distance. Therefore, you can't have a negative number because distance cannot be a negative value. You cannot walk a -10 feet. You might be able to walk 10 feet forward or 10 feet backward or step 10 feet to either side. You're just going a different direction, but the distance that you went from the original point to wherever you end up is still going to be a positive number. Therefore, absolute values cannot produce negative values. So in this case, where if it ends up being a negative, there is no solution. So let's look and see what we find on the next ones. On this one here, let me see, it is how many solutions are there? Well, we have it equal to 0, but we do see this 5 here. And I'm going to put my absolute value stuff on the left. I kind of like it on the left. So I'm going to rewrite this as absolute 5, and this is multiplication between here. 5 times the absolute value of j plus 8. Now we want to get the absolute value all by itself, right? So I need to go ahead and divide by 5. This is just kind of like if it were 5 times the quantity of j plus 8, where they were in parentheses instead of absolute value brackets. And whatever I do to one side, I'm going to do to the other. Those would cancel the 5s, leaving me the absolute value of j plus 8 equals, and 0 divided by 5 is still going to be 0. So in this case, it equals 0, and therefore you don't have it. There's no such thing as a -0. So this is going to be a situation where we have just one solution. And if we wanted to solve that, we would then just treat it as take away the absolute value brackets, do j plus 8, set it equal to 0, subtract 8 from each side, and j would equal -8. How many solutions does this equation have? Well, we have an absolute value. Again, I like mine on the left, so 9u. And that is supposed to equal -6. Well, problem. We can't get an absolute value that's going to produce a negative number. It's impossible. All absolute values, whenever we calculate whatever is inside the absolute value bracket, and then we apply the absolute value concept to it, we're always going to get a positive number. So in this case, we're getting a negative number, so there is no solution. Now they want us to actually find the solutions to them, right? So let's go ahead and write these out. Again, I like my absolute values on the left. So I'm going to go ahead and rewrite that. 2 times the absolute value of w plus 5, and this should equal 6. So the 2 is locked onto the absolute value w plus 5 through multiplication. The opposite operation is division. Every fraction is a division problem. We're going to divide by the number we wish to get rid of, which is 2, and what we do to one side, we're going to do to the other. So the 2's will cancel each other, and we end up with absolute value of w plus 5 equals 3. I've now isolated my absolute value portion on one side of the equation. Now I'm going to create my 2 special cases. So first case is w plus 5 could equal a -3, and then the other case is w plus 5 could equal a +3. Let's go ahead and solve these. Let's go ahead and subtract 5 from each side. And whenever I do that, I'm going to end up with just w on the left, and -3 minus 5 is going to be -8. So one solution is -8. And then on the other side, again, I'm going to subtract 5. Subtract 5, and the 5's will cancel each other, leaving me with just w. And 3 minus 5 is going to be a -2. So my other solution is -2, -8, and -2. Here I have the absolute value of 4p. is set equal to the value of 4. So absolute value is already isolated. I can now create my two special cases. So I'm going to take what's inside the absolute value bracket there, 4p. I'm going to set it equal to a negative form of what I see on the right. And then I'm also going to set it to a positive form. And then divide both sides by 4. P equals -1. And over here divide by 4. P equals +1. So -1 and +1. On the next one, I have 9 times the absolute value of g minus 1, and that's going to equal 18. So the 9 is tied to the absolute value of g minus 1 through multiplication. The opposite operation is division. I'm going to divide by the very number I wish to get rid of, and what I do to one side, I'm going to do to the other. I do that because I want the 9s to cancel each other, leave me with the absolute value of g minus 1 on the left, and 18 divided by 9 is 2. I now have the absolute value portion isolated on one side. I can create my two special cases. First case, g minus 1 equals -2. And second case, g minus 1 equals +2. Let's go ahead and add 1 to each side. Over here, adding 1 would get rid of -1. -2 plus 1 is -1. And over here, if I add 1, 2 plus 1 is 3. My two solutions are -1 and +3. Here we have the absolute value of -2q, and I'm going to add 8 to that, and then that should equal 16. Well, before I can do my two special cases, I need to isolate that absolute value portion of the equation. So let's go ahead and subtract 8 from each side. By doing that, it's going to get rid of those 8s, leave me with just the absolute value of -2q. And that would equal, and 16 minus 8 is going to be 8. Now I can set up my situation where I have two special cases. I want to call them mini equations, but they're actually just case 1, where I have -2q could equal -8, or -2q could equal +8. So let's divide both sides by -2. I do that because I want these -2's to cancel each other. Leave me with just q on the left, and negative divided by negative is positive. 8 divided by 2 is 4. Over here, I'm going to divide by -2 as well again. And those are going to cancel each other. Leave me with just q. And positive divided by negative is negative. And again, 8 divided by 2 is 4. So my two solutions are -4 and +4. Here I have -5 times the absolute value of -4s equals -9. Now you might be thinking, oh wow, wait a second, it's equals a negative, so it can't equal a negative. Well, not so fast. Watch what's going to happen. We need to get rid of this -5 that's tied to the absolute value of -4s through multiplication. So we're going to divide by the number we want to get rid of. And what we do to one side, we do to the other. Now you see what's going to happen? Those -5s are going to cancel each other, leaving us with the absolute value of -4s equals negative divided by negative is positive, right? And 9 divided by 5 is going to be 9/5. We'll just leave it as a fraction of 9/5. So now we need to create two mini equations, and by doing so, we're going to create -4s equals -9/5, and then also we'll do -4s equals a +9/5. So on this one here, I'm like dividing by -4, right? I want to divide by -4. Well, over here on the left, I'm dividing -9/5 by -4. So I'm going to do some work on the side up here. -9/5, and I want to do it divided by 4. But I'm going to write 4 as a fraction, 4/1. Now, and I'm dividing by -4. Okay. And now I'm going to do keep, flip, change. Keep the first, because these are fractions, dividing fractions. So keep the first, flip the second. I'm going to keep my negative sign up top, and change the sign. now we can multiply. Now I can do negative times negative is positive. 9 times 1 is 9. And 5 times 4 is 20. So I would end up with S equals 9 over 20. So in this case here, we'll do it again. We'll say it again because I'm going to do it with the 9/5 here. So what I'm going to do again is I'm going to go ahead and take the 9, I'm going to divide by negative 4. Divide by negative 4. So I need to divide 9/5 by negative 4. So 9 over 5 divided by negative 4. Yeah, I did negative 9. Okay. And now I want to rewrite negative 4 as a fraction. Negative 4 over 1. Now I'm going to do keep, flip, change because this is multiplying fractions. This is divide fractions. I'm going to go ahead and use the keep, flip, change so I can multiply fractions. So keep the first, 9 over 5. Flip the second, 1 over 4, and change the sign. Now, not negative, and positive times negative is negative. 9 times 1 is 9, and 5 times 4 is 20. So in this case, S equals negative 9 over 20. So these are my two solutions, negative 9 over 20 and positive 9 over 20. Wow, love those fractions, don't we? So on the next one, we have, again, I like my absolute values on the left, 5 minus 2v, absolute value of 5 minus 2v. Going to add 5 to that, and that should equal 9. So let's go ahead and subtract 5 from each side. And whenever I do that, those 5's cancel, and I end up with absolute value of 5 minus 2v equals, and 9 minus 5 is 4. But there we go, get my absolute value sign in there. Am I good to go? Yep, I'm good to go. So now let's make our two special cases. 5 minus 2v equals negative 4, or 5 minus 2v equals positive 4. So let's go ahead and subtract 5 from this side, get negative 2v, and subtract 5 over here, and I would get a negative 9. Now let's go ahead and divide both sides by 2, and I'm going to get 9 over 2. So one solution is going to be 9 over 2. On the next one over here, which I think it's going to be, I guess, negative 9 over 2 most likely, let's go ahead and subtract, well, actually might not work out. Yeah, let's go ahead and subtract 5, minus 5. So actually it's not. Okay, different answer. Those will cancel each other, end up with negative 2v, and 4 minus 5 equals negative 1. Here we go. Then let's divide both sides by negative 2, and we'll end up with a positive 1/2. So we end up with 1 over 2. So our solutions are 9/2, and they're both positive, right? Yeah. Yep, both positive. Here we have, wow, a little bit of work on this one. Negative 4 times the absolute value of 2d minus 1 minus 4 equals 7. Now let's go ahead and add 4. We'll add 4 to get rid of the negative 4. Got to do that first. That's going to leave us with negative 4 times the absolute value of 2d minus 1, and then 7 plus 4. Oh, that's negative 7. Whew, close. Would have gave me the wrong answer. Always be sure you transpose it, transfer it, whatever, rewrite correctly. So negative 4 or negative 7 plus 4 is going to be negative 3. Now I need to divide by negative 4. And I'm going to get, those are going to cancel. Leave me an absolute value of 2d minus 1. And then a negative divided by negative is positive, and 3 divided by 4, we'll just leave that as 3 over 4. Now that we have our absolute value portion isolated on one side, let's go ahead and create our two mini equations, or two special cases, I guess. 2d minus 1 is going to equal a negative 3 over 4. And our other situation is 2d minus 1 is going to equal positive 3 over 4. So let's go ahead and, oh goody goody, I get to deal with fractions, right? Let's go ahead and add 1 to the side and I'm going to add 1 to the other side. I'll do that in a moment. But those are going to cancel each other, leaving me with 2d. Now I need to do negative 3/4 plus 1. Well, I'm dealing with force, so I'm going to rewrite 1 as 4/4. Since I already have a denominator of 4, and any number over itself is equal to 1, so I just rewrote the positive 1 as 4/4. Negative 3 plus 4 is positive 1, and we're dealing with force. So that equals 1/4. So we're up to that point. Now, let's go ahead and do the next one. Get the next one over here, as long as I'm doing that. So let's do over here. I'm going to add 1 to this as well. And why I'm writing 3, I do not know. I'm adding 1 to that. That's going to cancel each other. It's going to leave me with 2d equals 3/4 plus 1. So 3/4 plus 1, but instead of 1, I'm going to write 4/4. Same value, right? 3 plus 4 is 7, and we're dealing with force, so 7/4. Now I'm going to need some rewriting, some calculation space in a little bit, because now I'm going to divide by 2, right? I'm going to divide by 2, and that's going to give me just d, but 1/4 divided by 2, and I'm going to write 2 as 2/1. Let's do keep flip change, 1/4, flip the second, 1/2, change the sign. Now I can do 1 times 1 is 1, 4 times 2 is 8, and I end up with 1/8. Now on the other one over here, I'm going to divide by 2, and I also need to divide 7/4 by 2, so 7/4 divided by 2, I'm going to write 2 as 2/1. Now let's do keep flip change, keep the first, flip the second, change the sign. Now 7 times 1 is 7, 4 times 2 is 8, and I end up with d equals 7/8. So my two answers are 1/8 and 7/8. So keep up with that little bit of practice there you'll get with fraction addition, fraction multiplication, etc. All right, final answer, or final question, which I guess will give me my 2 final answers, because there's 2 answers this one. So let's see. You might say, oh, it's a negative, it doesn't work, but we got some work to do. So that's probably going to change to a positive, because they do want 2 answers on this. So we have the 6 times the absolute value of 8 minus 5c minus 6 equals negative 6. So let's first deal with this minus 6 here by adding 6. And what we do to one side, we're going to do to the other. Ooh, interesting. I think I know. Okay, I see where it's going real quick. So these are going to cancel each other, right? And we're going to end up with, on the left, 6 times the absolute value of 8 minus 5c. And over here, this produces 0. And you're like, all of a sudden, oh, the 0's starting to show up. Now I need to divide by 6, right? Divide by 6. The 6's will cancel, and I end up with absolute value of 8 minus 5c equals 0. So at this point, we should realize we only have one answer, because we have the absolute value isolated on one side of the equation, and it equals 0 at this point. So we only have to do one equation to get one answer, and they want 2 places. They have 2 places for an answer, so we're just going to put the same answer in both slots. Okay. So in this case, let's take what's inside the absolute value, 8 minus 5c. We're going to set it equal to 0. We only have to do this once, because there's no such thing as negative 0. So let's see. Let's go ahead and add or subtract 8 from each side. So minus 8, and those 8's will cancel, leaving it negative 5c equals negative 8. And now let's go ahead and divide by negative 5. We do to one side, we're going to do to the other. Those will cancel each other, leave me with just c on the left, and negative divided by negative is positive. 8 divided by 5 is, well, 8/5. So we're going to put in 8/5. And we're going to do this for both of them, because we know that there's only one solution, because we get the absolute value isolated on the one side of the equation, and on the other side of the equation, it's set equal to 0. All right, so that concludes all of my examples for IXL A1.L.1 solve absolute value equations. Good luck with your activity.